So our next speaker is Dr. Stephen Kleiss, who's going to speak about advances in corneal topography. Thank you very much, Dr. Kleiss, for accepting our invitation.
Thank you very much for the invitation. I really appreciate being here. So Brad Randleman has taught us that the most important factor in detecting risk factors for ectasia is what? Abnormal corneal topography. And I'm sure you'll recognize that from his earlier work. So these are my relevant disclosures. So let's review some of the techniques used in measuring corneal topography. The most usual, the circular placido device is shown here. This pattern has been modified to a grid-style pattern with the eye design. Why? Because it helps eliminate some of the errors, the skew ray error that can occur in reconstructing corneal curvature. This is the Cassini. One of the advantages of the Cassini, they figured out that if they looked carefully, they could actually see the second Purkinje image reflection from the posterior corneal surface, and therefore, as Doug Koch has taught us, get an estimate of a posterior corneal astigmatism using a reflection technique. Dr. Huang has given an excellent talk on OCT, and the swept source OCT and the OCTs that he mentioned are critically important and very sensitive now for measuring layers in the cornea, not only epithelium, but anterior and posterior surface of the cornea. And then the slit scan devices, the Scheimpflug-based devices, have been very helpful in measuring pachymetry from the tomographic point of view. Examples of the circular placido devices are shown here. The K5M from Oculus is one example of the large disc placido, whereas the MedMont is one example of the cone-shaped placido disc that fits nicely inside the socket and is apt to give you a broader coverage of the corneal topography. These topography systems have been amplified and are now incorporating additional features other than simply measuring corneal topography. These are two examples of devices that also incorporate wavefront aberrometry. And in addition to that, some of the placido devices have also gone to using rotating Scheimpflug slits in order to measure both surfaces of the cornea as well as the cylinder on both sides and the pachymetry of those surfaces, as well as the standard reflection topography. Recently, some of the devices have added axial length in their measurement capabilities, and you can see three of these devices here. Some of them have placidos, the Pentacam does not, but what Pentacam has done just recently is they've added not only axial length, but wavefront aberrometry measurements to their device, and I think this is an exciting development. But for the future, we've heard a lot about Brillouin scattering and OCT and some very, very expensive technologies. But from a practical point of view, let's have a look at what might be coming down the line. A small, portable, smartphone-based topographer that sits on a slit lamp and sends its data to the cloud. This is codenamed Delphi at the moment, and it's a comparison here of my left cornea with the Magellan standard topographer and the Delphi unit. The optics of the Delphi are pretty amazing, and they figured out how to use a more sensitive camera to get much smaller, finer detail in the center of the cornea. Analyzing the central ring is only 200 microns in diameter. Basic system architecture of this device, as I said, it's smartphone based, and one of the nicest features is it has an auto capture system. The technician sits on a slit lamp, technician moves it around, and boom, it captures the image automatically. After the image is captured and approved, the exam is sent to the cloud, to a cloud server where the heavy-duty calculations are done for the various types of displays. And all of the displays are available then remotely to the provider with basically any device that has a web browser on it. Another one major and great advantage of putting all of the data in the cloud is that multiple devices can be placed all over the world, and all of these can send their data to the cloud and form a large database of several hundred thousand exams that then can be used for big data types analysis for the development using artificial intelligence of smarter screening algorithms. And I think this is very exciting. The other feature of having all the data in the cloud, it opens up the possibility to use corneal topography as one element of tele-ophthalmology, which is coming to you on short notice. It also allows virtual corneal topography screening. We've talked a lot about screening today. This approach, first the exam is captured in the clinic. The results of that exam are stored in the cloud. The AI system, which will be developed from a large database, then interprets the exam, and then that exam could be reviewed online. Now, what I want to point out is that all of the screening systems we've talked about today compared keratoconics with normal corneas. And the problem with doing that is if you don't, in the clinic, the patients that you have aren't going to be just keratoconics. They're going to have pellucid, they're going to have penetrating keratoplasty, they're going to have prior refractive surgery. And unless you train these systems on all of these different types of presentations, how can you say that any of these screening devices are specific? They're not specific in the clinic. They might be very specific when you train them only on 2 classes of cornea. So that's a very important point that I'd like to bring out. The other point I'd like to say about all the devices I showed you today is that they're all topographers or tomographers, but guess what? They also, they don't do all of these things, but look at the capabilities that are built into many of them. Pachymetry, wavefront aberrometry, pupillometry. There's even one that does air puff tonometry. Think, well, maybe biomechanics we can get out of that one. Autorefraction, screening programs, biometry, cataract grading, dry eye metrics, contact lens fitting. All of these things are available on one or more of the corneal topography devices today. Gee, what if we could put that all in one box? Well, who's going to pay for it? It'll be very expensive to build, and this box, at least nowadays, will be the size of the exam room. So that's a problem. But what I predict, though, is that there will be a paradigm shift from the big box legacy diagnostic instruments. We will head toward low-cost topographers that are multifunction. They're compact, portable, slit lamp based, and that they're networked and store all of their data in the cloud, providing the opportunity for big data analysis, for smarter, more effective screening programs, and finally, to open up corneal topography as part of telemedicine. Thank you.